In this video, we're going to complete the KutaSoftware Infinite PreAlgebra free worksheet, Divisibility and Factors. I'll leave a link in the video description below so you know how to access this free worksheet. For this first section, we're going to state if the first number is divisible by the second number. So let's jump into number 1. In number 1, it says, is 60, the first number, divisible by 2? The second number. Now, in order to know if a number is divisible by 2, it's going to be an even number, meaning that in the ones place, there will be either a 0, a 2, a 4, a 6, or an 8. And again, if we see any of these numbers in that ones place, it's an even number and therefore divisible by 2. If we see any of those in the ones place, it's divisible by 2. So because 60 has a 0 in the ones place, yes, it is divisible by 2. In number 2, it asks if 49 is divisible by 6. Now, in order for a number to be divisible by 6, so I'll just write this as div by 6, it has to be 1 divisible by 2, and it also has to be divisible by 3. Now I'll go over divisibility by 3 in a few minutes. However, because 49 is an odd number, not ending in 0, 2, 4, 6, or 8, it's not divisible by 2. It's not an even number, it's not divisible by 2, and because it's not divisible by 2, it is not divisible by 6. So the answer in number 2 is no. In order for it to be divisible by 6, it has to be divisible by 2 and divisible by 3. And because it fails the first, we don't even need to check to make sure it's divisible by 3. So let's move on to number 3. In number 3, it says, is 92 divisible by 10? In order for a number to be divisible by 10, so I'll write this as divisible by 10, it needs to end in a 0. It needs to have a 0 in the ones place. And because in number 3, 92 does not have a 0 in the ones place, it has a 2, then our answer for number 3 is no. It is not divisible by 10. For number 4, it says 72 divisible by 6. Remember, in order to be divisible by 6, there's 2 things we have to check. Divisible by 2. Yup, 72 is divisible by 2 because, and I'll put a check mark, it ends in 2. A 2 is in the ones place, therefore it's divisible by 2. Now we need to check if it's divisible by 3. And being divisible by 3 means that the digits sum to give us a number that's also divisible by 3. Now that can be a bit confusing when saying it in words, but it's actually quite simple. We'll take this digit 7 and add it to 2. 7 plus 2 will give us 9. So we have to ask ourselves, is 9 divisible by 3? And that answer is yes, because 3 goes evenly into 9 3 times. Remember, 3 times 3 is 9. So in number 4, 72 is both divisible by 2 and check, it's divisible by 3. Therefore, because it's divisible by both of those, and that's the criteria for being divisible by 6, our answer is yes for number 4. It is indeed divisible by 6. So let's continue on to number 5. In number 5, it asks, is 66 divisible by 3? So again, in order to see if something is divisible by 3, we need to sum the digits. So we'll take 6 and add it to 6. 6 plus 6 is equal to 12. And 12 is 4 times 3. So because 3 is a factor of 12, otherwise known as 12 being divisible by 3, because that's true, then our number 66 is divisible by 3. So our answer in number 5 is yes. Moving on to number 6, it asks if 72 is divisible by 3. But if you remember, for number 4, we already checked that. And here's a good thing to think about. If a number is already divisible by 6, then it has to be divisible by 3 because a number that's divisible by 3 is a prerequisite. In other words, it's a stepping stone for that number being divisible by 6. So because 72 is divisible by 6, it has to also be divisible by 3, since being divisible by 6 is being divisible by both 2 and 3. But just in case you forgot, and for extra practice, let's add 7 to 2. So 7 plus 2 will give us 9, and 9 is 3 times 3. So it is indeed divisible by 3. So yes is our answer for number 6. Now 7, we got asked a new question. Is 684 divisible by 9? Now, in order for a number to be divisible by 9, the sum of the digits also has to be divisible by 9. So we'll add 6 to 8 and 4. 6 plus 8 is 14, and 14 plus 4 is 18. So our new question is 18 divisible by 9? If that's true, then 684 is also divisible by 9. So 18 is 2 times 9, so it is indeed divisible by 9 because 18 divided by 9 is the number 2. So our solution in number 7 is yes. In number 8, it asked, is 555 divisible by 3? So we know we got to sum those digits. 5 plus 5 plus 5 is equal to 15, which 15 is 3 times 5. So yes, because 15 is divisible by 3, 555 is divisible by 3. Also, another trick for number 8 is because we have 3 5s, as opposed to writing this as 5 plus 5 plus 5, we could write it as 3 times 5. And we know that this number, we have a factor of 3 and 5, therefore whatever number we get as a result has to be divisible by 3, since we're using 3 to multiply to get that number. Now on to number 9. And number 9 is 608 divisible by 2. 608 ends in an 8, so it ends in a 0, 2, 4, 6, or 8. Therefore, yes, it is divisible by 2. Number 10 is 767 divisible by 9. If the sum of those digits is divisible by 9, then that number itself is. So 7 plus 6 plus 7 is going to be equal to 7 plus 6 is 13, and 13 plus 7 is a positive 20. And if we try to divide 20 by 9, we will get a decimal. 9 does not go into 20 evenly, therefore, no, 767 is not divisible by 9. On to number 11. 708. Is it divisible by 6? Well, first we need to check, is it divisible by 2? Then we need to check, is it divisible by 3? Well, first of all, 708 ends in 8, therefore it's even and divisible by 2. Next, is it divisible by 3? 7 plus 0 plus 8 is equal to 15, and we know that 15 divided by 3 gives us a 5. So because 3 fits into 15 evenly, it's divisible by 3. Therefore, because 708 is divisible by both 2 and 3, it is indeed divisible by 6. So our solution in number 7 is yes. And then lastly for this section, number 12. Is 780 divided by 10? This is an easy one. Yes, it is, because there's a 0 in that ones place. And if you want to do the math real quick, 780 divided by 10, we simply move that decimal place 1 point to the left, dividing a number by 10, or we'll just cancel out that 0 to get 78. Let's continue on to the next page. In the next page, it says each number is divisible by which of the following? 2, 3, 5, 6, 9, and 10. So we're going to check each of those numbers, and a few of them will be quite easy to check. So I'll write the numbers we're checking for over here. So we're checking for 2, 3, 5, 6, 9, and 10. We're going to see if any of these are factors. So right away, we know that 319 is odd. It does not end in 0, 2, 4, 6, or 8, so it's not divisible by 2. And because it's not divisible by 2, and being divisible by 2 is a stepping stone to being divisible by 6, so we need it to be divisible by 2 in order to be divisible by 6, we can already X out that 6. Also, we'll be able to X out 5 and 10, because in order to be divisible by either of those, it needs to end in a 5 or 0, which it doesn't. So now let's see if it's divisible by 3. Sum these digits. 3 plus 1 plus 9 is equal to 13. Is 13 divisible by 3? No, 3 does not go into 13 evenly. The closest number that goes into 3 with 13 would be 12. So one away, we know it's not going to go into it evenly. And let's check for 9. 9 doesn't divide into 13, so we know it's not divisible by 9. So number 13, 319, is divisible by none of our list of numbers. None of those are factors of 319. Let's move on to number 14. And again, I'll list out my numbers on the side. 2, 3, 5, 6, 9, and 10. So right away, the easiest ones to check would be 2, 5, and 10. It doesn't end in 0, so it's not divisible by 10. It doesn't end in 0 or 5, so it's not divisible by 5. So it's not divisible by 5 or 10, and also not divisible by 2 because it doesn't end in an even number. And remember, in order to be divisible by 6, it has to be divisible by 2, which it's not, so it's not divisible by 6. So let's sum these numbers. 4 plus 1 plus 1. 4 plus 1 plus 1 is equal to 5 plus 1, which is 6. And 6 is divisible by 3. But 6 is not divisible by 9. Therefore, the only number... Now on to number 15. In 15, we have 455. It doesn't end in 0, so it's not divisible by 10. It ends in 5, so it's divisible by 5. It doesn't end in an even number, 0, 2, 4, 6, or 8, so it's not divisible by 2. And if it's not divisible by 2, it's not divisible by 6. So let's see if 4 plus 5 plus 5 are divisible by 3 or 9. 4 plus 5 is 9, and 9 plus 5 is 14. Now, we can check to see if it's divisible by 3 and 9, but think about this. 3 goes into 9 evenly. So if a number is divisible by 9, it's also divisible by 3. With that being said, if it's not divisible by 9, it's also not divisible by 3. So since 14 is not divisible by 9, it's also not divisible by 3. Therefore, in number 15, the only number that it's divisible by is 5 for the numbers that we're looking at. In number 14, let's check. 2, 3, 5, 6, 9, and 10. It doesn't end in 0, so it's not divisible by 10. It doesn't end in 5 or 0, since we already checked that, so it's not divisible by 5. It is, however, divisible by 2 because it ends in an even number. 0, 2, 4 is even number. So it is divisible by 2, which means it could potentially be divisible by 6. But we got to check if it's divisible by 3 first. So 4 plus 1 plus 4. 4 plus 1 is 5. 5 plus 4 is 9. 9 is indeed divisible by 3. And because it's divisible by both 2 and 3, it's divisible by 6. And 9 is also divisible by 9. So in number 16, the number is divisible by 2, 3, 6, and 9. In number 17, we have the number 382. It doesn't end in 0 and it doesn't end in 5, so it's not divisible by 5 or 10. It does, however, end in 2, so it's divisible by 2. Now, we need to check if it's divisible by 3. 3 plus 8 plus 2, 3 plus 8 is 11, and 11 plus 2 is 13. 13 is unfortunately not divisible by 3, so it's not divisible by 3, and because it's not divisible by 3, it cannot be divisible by 6. Because in order for it to be divisible by 6, it has to be both of these, which it's not, and 9 also does not go into 13. It also is not divisible by 9. So in 17, it's only divisible by 2. For number 18, it doesn't end in 0 or 5, so it's not divisible by 10. And because it doesn't end in 0 or 5, it's also not divisible by 5. It is, however, ending in an even number. There's a 6 in the ones place, so it's divisible by 2. Let's check to see if it's divisible by 3. 2 plus 5 plus 6. 2 plus 5 is 7. 7 plus 6 is 13. 13 is not divisible by 3, and therefore it's not divisible by 6 or 9. Because if it's not divisible by 3, it's definitely not divisible by 9, since 3 fits into 9 evenly. Therefore, it's only divisible by 2. Now for number 19, we have the number 492. It's not ending in a 0 or a 5, so it's not divisible by 5, and since it doesn't end in 0, it's not divisible by 10, but it does end in a 2, so it's divisible by 2. Now we'll sum those digits. 4 plus 9 plus 2 is going to be 13 plus 2, which is 15. 15 is indeed divisible by 3, and therefore, since it's both divisible by 2 and 3, it's also divisible by 6. However, 9 does not divide into 15 evenly. Therefore, it is not divisible by 9. So, 2, 3, and 6 are our solutions for number 19. In number 20, we have the number 410. And right away, I can see that it ends in a 0. So because it ends in a 0, it's divisible by 2, 5, and 10. Because like I stated earlier, if it's divisible by 10, it's not only even, but it's also divisible by 5 because it ends in that 0. And in order for it to be divisible by 5, it needs to end in a 0 or 5. Now let's check to see if it's divisible by 3. If it's not, it's also not divisible by 6 or 9. So 4 plus 1 plus 0 is equal to 5, which is not divisible by 3. Therefore, it's not divisible by 6 or 9. So for number 20, it's divisible by 2, 5, and 10. For number 21, we have the number 297. Let's check to see if it's divisible by 10. It doesn't end in a 0, so it's not. Checking for 5, it doesn't end in a 5 or 0, so it's not. Checking for 2, it doesn't end in an even number, so it's also not divisible by 2. And if it's not divisible by 2, it's not divisible by 6. So we're left with 3 and 9. 2 plus 9 plus 7 is equal to 2 plus 9 is 11, and 11 plus 7 is 18. And because 18 is divisible by 9, that means it's also divisible by 3. 3 times 6 gives us 18, and 9 times 2 gives us 18. So 3 and 9 are both factors, and therefore our number 297 is divisible by both 3 and 9. And number 22, it doesn't end in 0, so it's not divisible by 10. However, it is divisible by 5. Now let's check if it's even. which is easy to tell because it ends in an odd number and therefore is not divisible by 2. Next, let's check if it's divisible by 3, because we've already eliminated 6 since it's not divisible by 2. And if it's not divisible by 3, it's also not divisible by 9. 4 plus 2 is 6, and 6 plus 5 is 11. So we know that 11 is not divisible by 3, therefore this number in 22 is also not divisible by 9. So the only factor of 425 is 5. Therefore, the only number 425 is divisible by, within our list of numbers, is 5. So again, it's not divisible by 10 because it doesn't end in 0. 5, it ends in 5. 2, it's not divisible by because it's not even. And 3 does not go into 11 evenly, so it's not divisible by 3, 6, or 9. For number 23, we're getting into a little bit larger number, but the same rules still apply. So we'll check 2, 3, 5, 6, 9, and 10. It doesn't end in 0 and it doesn't end in 5, so we can eliminate 5 and 10. It does end in an even number 2, so it's divisible by 2, which means we can't rule out this 6 yet. First, we got to check for 3. 9 plus 9 plus 4 plus 2, that's going to be 18 plus 6. And 18 plus 6 is 24. Or we can think of this as 18 plus 4, which is 22, plus 2, which is 24. And 24 is indeed divisible by 3. That's 3 times 8. So because it's divisible by 2 and 3, it's also divisible by 6. However, 9 does not divide into 24 evenly, therefore it's not divisible by 9. So in number 23, we have 3 numbers that 9,942 are divisible by, and that's 2, 3, and 6. 2, 3, and 6 are all factors. If you're divisible by a number, that number is a factor. In number 24, let's see if 2, 3, 5, 6, 9, or 10, if any of those numbers are factors. So, it's an even number, so it's divisible by 2, but it doesn't end in 0 or 5, so it's not 5 or 10. Now let's sum those numbers. 8 plus 9 plus 3 plus 8. 8 plus 9 is 17, 17 plus 3 is 20, and 20 plus 8 is 28. 28 is not divisible by 3, therefore we're not divisible by 6 or 9. So in number 24, the only factor from our list is a 2. 3, 5, 6, 9, and 10, none of those are factors. Again, just 2 is our answer. Now our second to last problem, number 25. If you found this video helpful so far, go ahead, click that thumbs up button, and also subscribe to my channel. All likes and subscriptions are greatly appreciated. Now let's dive into 25. In 25, we're going to check to see which of the following numbers are factors. 2, 3, 5, 6, 9, and 10. Well, it's not even, so it's not divisible by 2. It doesn't end in 5 or 0, so it's not divisible by 5 or 10. Now let's sum these digits to see if it's divisible by 3. 7 plus 6 plus 1 plus 3, that's going to equal 17. 1 plus 3 is 4, 4 plus 6 is 10, and 10 plus 7 is 17. Or you can think of this as 7 plus 6 is 13, 13 plus 1 is 14, 14 plus 3 is 17. Remember, addition is commutative, so the order in which you add does not matter. But 17 is not divisible by 3, and if it's not divisible by 3, we know it's not divisible by 9, and since it's not divisible by 2 or 3, it's also not divisible by 6. Therefore, it's not divisible by any of our numbers. None of our numbers are factors. And now the last one, number 26. It's not divisible by 2, but we need to check if 3 is a factor, 5 is a factor, 6 is a factor, 9 is a factor, and check if 10 is a factor. It's not divisible by 5 because it doesn't end in 5 or 0, and it's not divisible by 10 because it doesn't end in 0. So it's not divisible by 2 because it's not even, it's not divisible by 5 because it doesn't end in 5 or 0, and it's not divisible by 10 because it doesn't end in a 0. So 2, 5, and 10 are not factors, and because 2 isn't a factor, 6 isn't a factor. So all we need to check for is if it's divisible by 3, and if it's not, then it's not divisible by 9. So we'll add 7 to 8, 4, and 9. 7 plus 8 is 15, 15 plus 4 is 19, and 19 plus 19 is 28. 28 is not divisible by 3, therefore, in number 26, none of the numbers from our list are factors. And with that, we wrap up our divisibility and factors worksheet. So the biggest takeaway from this worksheet is understanding the term divisibility and factors. If a number is divisible by a number, then that number that it's divisible by is a factor. For example, in number 24, because 8,938 was divisible by 2, that made 2 a factor of that number. And in number 26, none of them were factors because none of them divided evenly into that. So before continuing on, just like I said in the second to last problem on this worksheet, don't forget to like, subscribe, and share. Also, go to maemap.com, maemap.com for more lessons, tutorials, worksheets, and fun.